Hi, I just wanted to record a little bit of sharing about some research we've done to learning how to buy inventory management software. I work at a small to medium-sized enterprise, and I have been helping the people I work for to find something that suits their needs. So let's jump right into it. By the way, I'm based in Malaysia. Okay. Okay, so we're based in the lifestyle sector, specifically food and beverage. We have 4 outlets and 2 factories. So obviously, the need to bring in new software comes from a need to grow, and we're hoping to grow in size, and therefore people think we should have software to automate more things so we can have our human people do more useful things than just sitting around jotting notes about inventory all the time. Some of our outlets are factories too, which means that we have multiple internal and external customers and multiple internal and external suppliers. And sometimes a single premise is both a supplier and a factory, or rather a supplier and a customer to different parties. Let me move on. So looking at a bunch of different types of providers, some responses we got were, okay, for the smaller software houses, we found that people are very focused on what they want to do, of course. That's where they make their money. Some would say, we are a point of sale system and we don't want to integrate with procurement. Perfect. But that doesn't help us. Some others might say, we want to track procurement approvals. So they're designed to be a procurement management software. And then they don't manage inventory, which kind of sucks because we want both altogether. Some people say we track inventory really well, but we don't want to manage the procurement or sales process. And so what we have is the ability to track stuff in one place, but not the ability to track it as it moves out from those places. None of that was super helpful, so we had to keep looking. We got to some bigger companies, and then we find that, we're still considering these. These might be just the right fit. They have all the features, but they're still standalone. They don't integrate with their own accounting system or their own POS or their own HR tracking system and so on and so forth. Go a bit bigger and you're going to find people like SAP and Oracle who basically want to do everything. But if they give you a solution, they want you to use their entire solution and kill all your other software because they want to have it all. Okay, so in no particular order, some vendors we looked at, some of which are in Malaysia, but a lot of which are from all around the world and they're just on the internet. And we got to look at those. Part of the due diligence we had to do is to then look at all those solutions and the options that they provided, and then try and see what it would look like if we wrote the software ourselves. Just, we're not going to do it, but we had to know. So here we go. So the process of procurement, buying things and selling things too. So it's a process. Generically, we want to be able to log the process so that people can audit the process of buying and selling things. Here's a sketch of the workflow. When you have internal customers, can you see my mouse? Oh, yes, you can. Okay, internal customers selling to internal suppliers. It's basically you and your buddy in the same company ordering stuff from each other. But sometimes you order stuff from your buddy and your buddy doesn't have it, so he's got to go outside and buy something from somewhere else. And so an internal supplier may in turn source stuff from external suppliers. Roughly, the process is going to look like over here. It begins with what we might call a requisition order, a purchase request, or just a requisition, right? So that goes to a hub of some sort where they're the internal supplier. And if he already has the thing in hand, he goes straight and makes it into a pack. And then from the pack, he can ship it back to the person who asked for it. And when the person who asked for it gets it, they have to log sort of a receipt, I've received the goods. But if the internal supplier doesn't have it, they will have to detour a little bit to go outside, send a purchase order out of the company, get a goods receipt back, and then proceed back with the packing and then delivery. And then, the internal guy finally gets it, the customer. Now, if you have also tracking of external customers, so you want to sell out from your company, and you want to sell stuff outside to, okay, whoops. No, this is wrong. This is about external customers when we sell from our company out. We sell out from our company, and then what you get is a process where sales orders come in from outside. We may or may not have to buy more things before we finally pack stuff and send it back out to the external customers. Okay, so roughly we've got all those things covered. Okay, moving on. But what does that look like at the actual database design step? This is a sketch. It's not going to be 100% correct, but it's kind of a step in the direction to kind of understand what we have to do to be able to track all these things. Okay, so for example, a requisition order, which is the internal customer asking the internal supplier, please send me some stuff. You would want to know, for example, the date time it was issued, the date time that you want the goods to arrive. You'd want to know the location where the goods would depart from, where they're being requested from, and you'd want to know the location where they're supposed to arrive. And of course, there's a requester, and typically there's an approver as well. Now, this approval process can get more complicated, but this is very generic, and you at least have one approver and one requester in this case, right? And then, of course, this requisition order is going to point to a bunch of assets, right? And so it's not just one asset, it's a map of assets. We'll get into that some other time if you are into database building. Anyway, now, if you have orders coming in from outside the company, external customers buying from us, then again, you would want to track the date time that the salesperson is logging those external requests. You'd want to know what time the customer out there wants to get his stuff. You want to know the customer's ID. You want to have that list of assets that the customer is requesting. And of course, the user who is inputting all this would probably be a salesperson, so we'd ID them as a salesperson, right? Now, that's one set of documents. Over here, we have purchase orders. Purchase orders are when we as a company buy stuff from outside. So again, blah, 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 the dates, the locations, the requisition orders, which are related, because sometimes you get a bunch of internal requests for stuff. You want to group them all together and make one purchase order to the outside supplier to get stuff back in. So a list of related requisition orders. And sometimes a purchase order may be because you want to serve not an internal customer, but an external customer. You need to buy stuff before you can serve your external customer. You're a middleman. So again, you would want to have the ability to link a bunch of sales orders coming in from outside to this purchase order, which lets you buy stuff, get the stuff, and send it back to all these other people who ordered it from outside your company. Okay. Goods receipts, generic. If anybody receives anything anywhere, they should have a goods receipt. They should be able to tick off the items that they received. And pretty much, sometimes that these items were received in response to an internal requisition order, which you issued, or they came from outside because you issued a purchase order and you got your stuff back. So you're ticking off the stuff that you just received right there. And that is generically what a goods receipt would behave like. Of course, you could call it different things. You could call it just a receipt. You could call it something else. I don't know. Okay, packing lists are just in case you want to pack things. For example, you've got a supplier come in, send you one box of balls. Okay, so you take the balls out and you put them into smaller bags where you got 50 balls in one carton, and now you sorted them into little bags, you have 3 balls each. Now you ship the balls back to different people who ordered bags of balls for whatever purpose. Okay, so if that's all good, finally you can work on delivery orders. When you actually send things out, you get a package of stuff, you've got a stamp on it, and you want to send it to somebody, whether it's an internal customer or an external customer. You would issue a document along with it that says, deliver this to whom and whom, so and so, where and where, and the person who takes it from you, the carrier or the transporter, signs for it. So these are generic documents. Moving on, but what are we tracking? So assets. Of course, we need to know how to document our assets in space and time. This is a very rough model again. We'd start by having lists of locations. Give them some names. So location is an abstract place with a name. We'd have some tags so that later on we can tag some of these entities. We'd have stock keeping units. For example, what shall we say? Frito-Lay chips, 250 grams. That's one type of thing. So there's lots of those things, but there's one type of thing. So all the things that are that type of thing would have the same store keeping unit or stock keeping unit, SKU for short. Industry people call it, commercial people call it all over the place, SKUs. But SKUs are abstract. Frito-Lay chips, 250 grams could refer to 100 different assets, 100 different bags, right? And so further on, we actually get to the final bit, the concrete asset that's being tracked should have an ID, a thing, an abstract thing, an X. It points to, I am this type of thing. It points to, I am a Frito-Lay 250 gram bag of chips. And because we don't want to have one single object there to track every single bag of chips, maybe we have 10 bags of chips and we just want to have a single object in the database track all of them. So an asset can have a count. You can point at, I'm Frito-Lay chips and I am 10 bags, not 1 bag. Okay, so these are very, very rudimentary structures in our sketch of how to model the data. right? Now we want to have hierarchies between some of these data objects as well. We have categories because products, SKUs, the Frito-Lay chips can be a type of chip, and the chip can be a type of snack, and snack can be a type of food, and so on and so forth. So we have a way for SKUs to be tagged. And then if you have categories, you want the tags to have a hierarchy, so they should point at each other with arrows. So down there you have the pointers. Okay. Similarly, if you have geospatial clustering, so you've got world and country and region and building and rack in the building, you have a hierarchy of space. And you can track all of these things if your location IDs have a parentage relation with other location IDs. Okay. Further on, we may have assets like that single asset, which was 10 bags of chips. And then we want to ship 5 to one place and 5 to another place. So we go and break it up. We break it up into 2 different assets with 5 bags of chips each. We'll go on to the algorithms, how to process that in a little bit. But roughly, this is what we're getting at. Okay, so the preceding tables discussed space, show dimensions. Not necessarily geospatial, but just spaces, abstract spaces, like things that have a dimensionality. And the following tables pertain to time, how those things change over a certain sequence. Okay, so back to our assets. We're talking about things that we track. Okay, so what we have is we use this accounting term journal, and journal means an entry which points at a change in something. So right now, the way we would do it here in this very rough sketch is that we would specify a date time for each journal, an asset ID, which points to one of those assets that we talked about up there. And then we would have locations where the asset is recorded to have departed and arrived. So every single asset journal tracks the movement of something, right? It tracks where it departs from, and it tracks where it arrives. So if you have a journal like this, you should never lose stuff if you always track your journals and keep them nice and tidy. Okay, there are some algorithms here for like, okay, if we want to create an asset location, we basically create first the asset object up there, then we create an asset journal object, and we fill in where it departs from and where it arrives from. Let's say we want to delete. Oh, by the way, yes, if you create an asset out of thin air, then it basically departs from nowhere and appears here. If you want to delete an asset here, it basically departs from here and then arrives at nowhere. So that's very simple. Moving an asset, basically, it both departs from here and arrives at somewhere else at once. So those are the rough operations you could do with this. Now, back to where we said we might want to split an asset and move it partially. You've got 10 bags of chips here, but you only want to leave 5 there and then move 5 somewhere else. Here, it gets a little bit more complicated. But as described just now, you can call the original asset the parent, right? And we refer to, let's say we want to move 5 out, so that 5 is the moved portion. Okay, so what we do is we have one asset with 10 things in it. We create 2 child assets, right? Each of them having 5 things in it. We make a record in the asset tree that says these 2 things with 5 assets each are children of that thing with 10 assets. But what that means is that now we're going to delete the record with 10 assets. So now we only have 2 assets with 5 things each, and then we're going to send one of those assets to a different location. So that's how we partially move an asset in this particular system. This is not the necessary way to do it. It is one possible way to do it. Okay. Further on to that, now we are moving things around, but we don't actually store the data until here about how much stuff is at any one place in total. So we have asset journals, and when you sum up the asset journals for a certain place, you should get the balance of all the movements in and out for that particular type of SKU. For example, let's say Frito-Lay chips 250 grams. If you track all the movements of Frito-Lay chips 250 grams in and out of a place, you'll finally know how many were there at that one place, right? So these balances you would compute every single time you wanted to know, and that's really expensive. So sometimes you don't want to do so much recounting. You actually want to, like, okay, we've counted it once. We're going to remember that we counted it again. We counted it once in the past, and then so that the next time we read it, we can see that, oh yeah, we recently counted it, and we're just going to like take that number and presume no one messed with the system so badly that we have to do a recount. So this is what you would typically in computing call a cache. You store some computed sum, and you want to reuse it later, so you don't have to do that computation so many times. Now, in this particular case, I have an algorithm that I'm just not going to bother talking about on screen. But basically what you do is that there are times when you can structure it so that when you do a count, you save the total so that you can reuse it later. And there are times when you want to like, okay, we know we've changed something. So all the previous items where we had done some sums, they're no longer relevant. For example, if you had computed some balances for how many Frito-Lay chips were in the system in January, right? And so if nothing changed and you came back in February, you could just read that previously computed sum, and you would know that the same amount of things was there, or you would assume that the same amount of things was there, and then that would be fine. Let's say you had records now from January to February and March, and every month there were things going in and out. So you had this whole long list of asset journals, right? And along the way, various people had come and read. Okay, I read the sum. Somebody had read how many Frito-Lay chips were at this place on January 15th and February 15th and on March 15th. Okay, so then you would probably have cached 3 sums. At those dates, somebody would have summed up all the counts of Frito-Lay chips at one place, and they'd have stored in this location SKU balances table, or whatever you call it, the cash value. So, let's say January 15th, you had 10 items, 10 bags of chips. And at February 15th, you had 20 bags of chips. And at March 15th, you've had maybe 30 bags of chips. Okay, so now say somebody goes in there and makes an entry. We want to go back and change history. We want to make a record that we forgot to record. We forgot to input this, right? So let's say we go back to February 1st and we say, oh, yes, by the way, 5 more bags of chips came in. So on January 15th, that balance of 10 bags of chips that we recorded, that doesn't really change because what happens in the future doesn't change past, right? But whatever balance we previously computed on February 15th for 20 bags of chips, because we've now added 5 bags of chips on February 1st, we want to invalidate the cache, which is the count of chips that we have on February 15th. In fact, we want to invalidate the record that we made for March 15th as well. So basically, if we make an entry to change the movement in and out of things on February the 1st, every cached sum after that has to be just deleted from the caching table. So roughly, this is how you'd save a little bit of computation effort and still have a feasible system that tracks a lot of things in really fine detail. And hopefully, that would be sufficient to build your system. And that's about all I have for now. I hope we figure this out because we haven't decided what we're going to do yet. Thanks for listening.